these days, customer experience or any customer expects and demand personalized, engaging, and seamless digital experience, right? And this experience is not a static goal. Typically, it's a journey, right? So, and any digital innovator who achieves this more quickly gets an edge on that, right? And any of your customer experience that you give to a customer comes from the application that you have designed. And for any application to be successful, you need a very strong operational database, right? But choosing a database has always been very tricky. And because there are certain challenges. If you talk about any RDBMS, you have challenges. If you talk about any distributed database, you have challenges. And NoSQL being latest in the era, it's again has its own challenges. So I have certain challenges that in my past experience I have faced, and I've tried to bundle all of them into 5 major challenges. So let's start by looking at that. But before even getting there, I would like to take a pause and see if any one of you want to quickly raise your hands or put a one-liner into the chat and tell me what are the typical database challenges that you have faced. Cool.
So maybe I can kick things off, Saurabh. So one question that I was very keen to get your take on and would love to get everyone's opinion on the call as we get into the discussion. So one thing which I've seen in my past experience working in a startup and across the founders, especially early stage who I interact with, it's a very usual part to start off with a database solution that you're very comfortable with as a developer, right? You have used a certain stack before and you start with that. And as you scale up your application and you start thinking about what could be the right architecture for a future-proof traffic volume or performance level that you have, what are some of the early signs as the product is scaling up where, which are good warning signs that, okay, you should rethink your database architecture, rethink your database solution, and how can teams watch out for those signs early on so that they can plan for it appropriately and not have to sort of firefight later on as, let's say, the application starts seeing a lot of traffic. It's less the case in B2B SaaS, as you can imagine, but in consumer tech, it happens a lot. So love to sort of plan this question. We can cover it at any point, but one broad question that I had from my side.
Thank you so much for the question, Anuraag. I think what I'm going to do is I've actually curated all these typical challenges into the next slides. So I'll try to cover most of that as to what are the common challenges we face. And you're absolutely right. See, developers, because these days the go-to-market time is so less that we we ought to make certain choices which is more comfortable rather than deciding as to what is best. Okay, so we mostly try to fit a circle in the square, and that is what in fact I have done in my earlier stages. It can help you in releasing the product fast, in trying to develop things fast, but eventually we get into problems which is very difficult to solve. Okay, and that brings me to my next slide as to what are those common challenges. See, what I've done is I've just tried to group these different problems into 5 broader topics. Let's start with scale. See, as you rightly said, once we start small, sometimes we want to make those conscious choices, but it's very difficult to predict as to what those scale could be, because scale is directly dependent upon the load. Some of that load can be anticipated, but some of the load cannot be anticipated. Those are unanticipated loads, right? Just to give you an example, suppose we are trying to build a micro blogging site, and we have just put a tweet or something, and it has gone viral, right? And because of that, the load on the micro blogging site that we would have created becomes 20x or 30x. You would have done your calculations, sizing, load testing based on 5x or 10x, but not based on 20x or 30x, right? So scaling is really a difficult problem to solve. Now, in the traditional databases, there were only one method to solve it, and that is vertical scaling, at least for the writes. And what does a vertical scale typically means is add the compute power, add the memory to
Yeah.
a particular database instance, right? And but even that has a limit. You cannot go beyond a certain limit, right? And in case you want to go, then there is lot other things that you might end up doing, which is again very difficult. And also this vertical scaling is not something that you can do without a downtime. You would need at least 30 minutes or 45 minutes to actually put more capacity and then restart it, right? So that's one problem. Another problem is with respect to operations, or even I would like to club another problem with this, which is reliability, right? The hardware breakdowns, right? We always have to make sure that our hardware is latest so that we don't get into, again, unanticipated downtimes. Hardware breakdown is one, but the other is the upgrades. For example, the database upgrades. You are on MySQL 5.7 and now it's 8. So you have to upgrade it, right? And sometimes it's forced, sometimes it's unforced, like end of life, right? Another challenges from an operation perspective could be performance tuning. We all have got into that problem. If you're using Postgres, the vacuuming problem, the typical problem, right? How do you tune that? And there is no thumb rule to do that. So all these operational hazards really makes it difficult for a database to work as we expect it to. Another challenge could be with respect to replication, right? So typically I talked about scaling. One is vertical scaling, another is horizontal scaling. Horizontal scaling is typically for if you're coming from a MySQL or a Postgres world, and you want to scale your reads, what you typically do is you add more replicas, correct? But once you add that, you get into different set of problems. Now, from master to read, it's an asynchronous replication, and the lag decides a lot of things, because you would have anticipated that it's mostly near real time with a lag of few seconds, but sometimes the lag becomes huge. It becomes in minutes, right? Sometimes even it can go to 15 to 20 minutes because of the load on your master database, right? So all those lags creates a lot of problem in your analytics, because sometimes your analytics or your reports that you run are real time, correct? So because of the lag, because of the incorrect or stale data, all those real-time reports that you're running from your replica can get into issues. Another problem is with respect to strong consistency. See, these days we know that there are different sort of databases, distributed databases that are available, right, which automatically shards your data. But how do you make sure that you get a strong consistency across all the shards, right? If you're writing to one shard and its replica is in probably another region or another zone, how do you make sure that when you're trying to read something, it's strongly consistent? So that's the challenge what we've got into in the recent times because of the evolution of the distributed databases. And last but not the least, a very important problem, again, what eventually we have got into recent times, is a combination of OLTP plus OLAP that we call it as HTAP. HTAP is hybrid transitional analytical processing. Briefly, I touched about it, which is running your reports on your real-time data, because we know we have gone through that problem of getting stale data from replicas. So eventually what we do is we move those reports out of the replicas and try to push them on the master. But the compute power, right, what a master needs increases exponentially. And on top of that, see, we do all understand that whenever you try to run a report, okay, whether it's a real time or it's a analytical report, the best database to run any report should have a columnar engine, correct? But if you try to move those reports on a database like MySQL or Postgres, they are row-based engines. Are you going to get the best out of those specifically for your reports, whether it's real-time or it's analytical reports, right? You can't get the best out of it, right? And so
Yeah.
what you end up doing is you end up investing a lot of compute and memory, okay, when you try to run these STAP reports on top of your OLTP systems. So what basically, these are some of the challenges which I have faced and I've tried to summarize in this 5 bullet points. But happy to hear if anyone else has faced any other problems, because primarily the next section of my presentation would focus on how to solve these challenges. Okay, but happy to hear from the attendees.
A couple of other problems actually we faced. One is like when you scale the data, having good coding practices. That makes sense because a lot of people comes in and they design the data according to their thing and mostly end up slowing down the entire process. That's the one thing we faced.
Got it.
Another one is like related to the archival process. Like basically, your operational database should have a limit of data.
Mhm.
Basically, if it is like every all the data is accumulated in operational database, eventually that is going to just slow down because it's going to consume a lot of
Of course.
uh, disk space. And so, how do you archive that? So that we have ran into several problems related to that because as the data goes up, like it tends to sometimes actually tends to eat up the whole disk space and kill the machine as it is. So setting up those kind of things and how to scale those kind of processes, it is also some of the challenges we have faced.
Got it. So, would you want to share on which particular database that you faced this issue of archival? Were you using MySQL, Postgres in
Yes,
the past?
MySQL. We are using MySQL.
Yeah, I think I was just thinking this whole movement towards hybrid transactional analytical processing, right? We see this trend obviously picking up because there is this confluence of different personas, right? You earlier used to have only developers who are focused and working with transactions, whereas you have more business folks and analysts who are working with analytics for any business use case. But those worlds are converging, and the right architecture which can enable this in a forward-looking manner would be something which is going to be huge. And we would love to also hear your thoughts, Saurabh, on what's the best way for teams to design this, which is not boiling the ocean at the same time, efficient, and is not taking away any capability of functionality from keeping these two worlds separate.
Absolutely, Anurag. Sure. Um, okay. I think I have tried to cover most of these in the next subsequent slides. So let's continue, and in case you have any other questions, stop me then and there. Yeah. See, so we have looked at these problems. Okay. So what in Google, what we have tried to do is we have basically identified these problems, and these are some of the problems that Google has been facing for last many years because of the scale and the complex use cases what we have in Google products. Like you talk about YouTube, Gmail, Google Photos, Google Ads, all of these complex and hugely immensely scalable use cases um, persist for a very long time. So what Google has internally done is that we have tried to solve these problems by some of the databases that we had actually built specifically for these use cases. And recently what we have done is we have exposed all these different services for the end users so that they don't have to reinvent the wheel and they can use all those intelligent smart systems that we have built and we are using to solve our problems, and you can just use them to solve your problems. Okay, so this is the Google Cloud database portfolio. Starting from left, we have certain databases which are there which can help you in in just to have a backward compatibility. So if you're embarking your journey on Google Cloud and you just want to do a lift and shift and you're on MySQL or typical Postgres or Oracle, you can just start using these services. But if you want to modernize your systems, if you want to solve your actual problem, it's the right side of the slide, which is typically a combination of AlloyDB, Spanner, Firestore, and Bigtable. These are the native database engines. We also, in the database portfolio, we also have certain services like the DMS, database migration service, and the data stream, which helps you in moving your data to these native database engines, as well as the managed third-party database engines. So let's try to see how the native databases that we have built solves all these problems that we have identified. Let's start with Spanner. Okay, so what is Spanner and how does it solve all these problems? Let's try to deep dive there. Okay, so Spanner is a database which is ACID compliant, ANSI SQL compliant, completely structured, but it gives you the benefit of a NoSQL database also, that is horizontal scalability. You also, I could not see the name, but someone also spoke about sharding as one of the challenge. So what Spanner also does is, Spanner also automatically shards your data. See, traditionally what we have been doing is, let me take an example of some traditional sharding technologies that we have used, like Galera, Galera cluster, right? What we need to do in that is we had to change our schema because we have to define a shard key. And on the basis of shard key, the data gets distributed, right? We had different other mechanisms also through which we could shard the data. But as you rightly pointed out, the application had to change. The model had to change. The data model had to be designed in the way through which it is shard compatible, right? And in fact, these days there are different databases which expects you to do this, right? So how does Spanner solves this? See, what Spanner internally does is, it doesn't expect you to have a shard key. It doesn't expect you to have any specific logic. What it just does is, it expects you to just bring your schema like what you have defined or designed on top of MySQL, Postgres, or any other RDBMS database. Okay. So what do you expect out of an RDBMS database? The very minimal construct is a table, right? What do you expect in a table? You just want a primary key. Spanner just expects you to have a table with a primary key. Of course, if you want to have additional constraints, you are free to bring them along. But the minimal requirement is a primary key. Now, what does Spanner does? Suppose you have a table, and taking a hypothetical example, suppose you have a table with 100 records, okay? And suppose the primary key is a sequence, 1 to 100. What Spanner does is, as soon as you start inserting a data into Spanner, it automatically takes a chunk of your data, that is 1 to 10 rows, and puts it into one shard. From 11 to 20, it puts into another shard. From 21 to 30, it puts into another shard. The shard, of course, you have to configure as to how many nodes you want to have in Spanner. And there are certain calculations on basis of which you can do that capacity planning. But the number of shards that you have already created, Spanner automatically distributes your data in it. It doesn't expect you to have any intelligence built in your application or in your code which actually distributes your data. Spanner does it for you. Okay, so that solves your sharding problem. You don't have to do anything extra at your code or at your table. Now, let's look at the other option, other challenges, what I spoke about, scalability. Okay, as I said, Spanner is a database that gives you the benefit that you get out of a NoSQL database in a SQL database, which is horizontal scalability. What does that mean? It means that I took an example of 100 records distributed into 3 shards. Now, say for example, your use case or the load on a particular application increases, and eventually you are having just not 100 records, you're having 1,000 records. And in fact, just not the records, but in fact now you're having 1,000 operations a second. Earlier, assume you were just having 100 operations a second. So can you still distribute into just 3 nodes? Probably yes, but in case your CPU, in case the resource utilization, you see that spiking up, you might want to add more shards, right? So in traditional databases, you might get into that complex process of moving your data, correct? But the best thing about Spanner, what it eventually does is, it is smart enough to figure out that what data has to be moved. What it means is, suppose you were having earlier 3 spanner nodes, and now you have said, I want one more node. I want to scale up my spanner instance to 4 nodes. Spanner automatically distributes your data. Okay. Now, you might have a question that in distributing the data, in moving the data from one node to another, it might take a lot of time. And that what brings me to my another differentiator of Spanner. And in fact, in that case, all the Google Cloud native databases, what they do is they distribute your compute layer and your storage layer. Okay, so your data is kept in a storage layer that we internally refer to as Colossus. So all your data is stored in Colossus. Now, what the compute layer basically does is compute layer just keeps a metadata about your data. Okay, so let's go back to the earlier example. Suppose you had 3 nodes and you had assumed 300 GB of data. So every node would have 100 GB of data, hypothetically. That's not how internally Spanner works, but let's just assume. Okay. So now, once you have added another node, that is 4 node, there would be movement of data in the traditional systems. But what Spanner does is, it still has the entire data in Colossus, but just the compute what you have added, and compute just holds the metadata about your data. Okay. So actually there is no data movement. It's just the metadata movement. And metadata is always in just few MBs. So actually there is no data movement whenever you add more shards, whenever you add more nodes to a Spanner cluster. Your data still resides in Colossus. It's just the movement of that metadata. And metadata being in few MBs, it's super duper fast. Which means now when you are trying to scale up, that is from 2 nodes or 3 nodes to 5 nodes or 10 nodes, you can do it instantaneously. There is absolutely zero downtime. There is no data movement, so you don't have to wait for the data to move from one node to another and to get your entire cluster stabilized. Okay, because it's the metadata, as I said earlier. So which means as soon as you go back and you go to a Google Cloud Console, and if you want to use that GUI, you just go to Spanner cluster GUI and you say earlier you had 3 nodes, now edit, make it to 4, save. Boom. And now you have 4 nodes. Your metadata is already moved. You don't even have a single second of downtime. You don't even have your impact on your P90s or P95s, and it's just working as usual. Okay. So that's what Spanner offers you. It gives you horizontal scalability. You can add as many nodes as you want. You can remove as many nodes as you want. Okay. So suppose there is a peak that you anticipate. Okay. So what you can now do is you can throw more capacity to Spanner and say there is a peak coming up. So I throw more capacity to it. From 10 nodes, I make it to 20 nodes only for that particular peak. And once that peak is over, I eventually remove all the nodes because there is no data movement. It is just within few seconds that can happen. Okay. And that few seconds is just to make sure that the metadata is updated. But for an application, there is absolutely no impact. I'll move forward.
Saurabh, could you speak a little bit about how this plays out in the migration case where people are coming from physical sharding to the sort of a virtual sharding environment? How does that happen, and does the team need to, what inputs they need to give to make sure migration is smooth?
Absolutely. Thanks for the question, Anuraag. So, see, if you have a sharded MySQL, what we have done is we have come up with some custom tooling which is built by Google. It's called as Google Migration Framework. You would have heard about HarborBridge. So HarborBridge is being rebranded, and Google's Spanner engineering team is actually working to make sure it makes the migration smoother. And one thread of that migration process is to bring the application sharded different MySQL shards or Postgres shards into a single spanner. Okay, so it's going to be as simple as like a plug and play option, which means a HarborBridge or the Google Migration Service could actually be plugged into your different MySQL shards, and you will just have to define that what is your shard key, and automatically this migration framework would tell you that this is what is going to be your end schema in Spanner look like. And if you accept it and you say that okay, I'm good with the schema, you migrate, your entire data with schema will be migrated. Okay, and if you just go back, I can share you some documentation offline, but there are step-by-step documents with a video which is already available on the Spanner documentation. Okay, does that help, Anurag?
Yeah, thank you.
Circling back, so I talked about the horizontal scalability, right? You can add nodes with few clicks, you can remove nodes with few clicks, but again, it doesn't solve one of the problem that I spoke about, which is an unanticipated load. Okay, suppose again, let me take an example of the microblogging site, and because we all understand Twitter, let me just name it as Twitter. Actually, I'm just trying to give you a reference. Okay, so suppose it's a microblogging site, and like Twitter, someone has tweeted something, okay, which has gone viral during the late India hours, right? No one would have anticipated that you would have got 30x or 40x more load. How do we cater such unanticipated peak in our applications? Correct? It's very difficult. So if it would have been a traditional system like a MySQL or Postgres, that would just go down. Correct? So in Spanner, yes, we can do that horizontal scale up and scale down. But it also has a feature which is auto scale up and auto scale down. Okay, which means now you just don't have to do everything manually. What you can also do is you can configure an auto scaling capabilities. Okay, what does that mean is Spanner is an intelligent database which senses your load. Okay, and once it senses that there is more load coming, and those are all configurable parameters what you have. One such parameter is, for example, CPU. So once your CPU spikes up, Spanner automatically figures out that, okay, there is more load coming up, which is actually increasing my CPU. And suppose you have defined a threshold of 70%. Once the CPU spikes up to 70%, Spanner would automatically scale up your nodes. And the maximum number of nodes again is a defined parameter that you can control. So you can now tell Spanner that currently you are at 2, maximum you can go up to 10 to make or to have all that controls in your hand. Okay, and once the CPU goes beyond 40%, automatically scale it down. Now scale it down to probably 4 nodes or 2 nodes or 3 nodes. Okay, suppose you have and the best benefit of this auto scaling feature is, say suppose you have an application where you have 3x or 4x of peak during your day, multiple hours in a day. So eventually with Postgres or MySQL, what you have done is you would have over provisioned. Correct? During the late night hours in India time, you would see probably a CPU of 5 or 10%. Okay, so that's so much of wastage of resources, which increases your cost, right? So what now you can do with Spanner is you can actually have these auto scale up and auto scale down capabilities used, which can actually bring down your entire Spanner cluster to less than one node. In Spanner terms, we call it as granular instances, which means that you don't even need one node. What you can do is you can actually scale down to 1/10th of a node. And 1/10th of a node, if you run it for entire 730 hours, charges you just around $70. Okay, so which means if you don't have traffic coming in, you can scale down as low as to 1/10th of a node and save a lot of cost. And eventually, once in the morning or in the afternoon, once you expect traffic, automatically because of the auto scaling capabilities, Spanner would automatically scale up. Okay, I'll take a pause and see if you have any questions. Cool. I'll just talk about or glance through some of the other features that you expect out of any production grade database, and some more differentiators that I did not speak about, which is very simplified administration. So what in all the native Google native database offerings, we have also built in very robust monitoring. Okay, starting from checking what are the different explain plans of a query. Okay, in the last 1 hour or in 7 days or in 1 month. We all understand SQL can have different explain plans, right? So if you want to probably check that till that level, now you don't even have to execute a command. You can just go to the Spanner console, or in that case, any native database offering of Google. You can just go to the console and you have monitoring tools available. We call it as insights. Okay, so you have Cloud SQL insights, you have AlloyDB insights, you have Spanner insights. You want to see which query is acquiring a log for how long. You can just go to the insights page and eventually figure that out. Okay, so the monitoring is very simple. Because of that, the administration has become very simple, and you can configure all sort of different alerts what you want to do. Another very important feature what Spanner also offers you is global replication. If you want to have your Spanner database spanned across multiple regions, okay, in India, in Europe, and in US, you want to have just one single Spanner cluster, and the nodes distributed across all these regions. You can have that. Okay, so it's again, as I also spoke about automatic sharding. So Spanner allows you to shard your data automatically. You don't have to do anything. Being a distributed database, you might also have a question as to how does a failover works? How does a failure works of a particular node? So by default, Spanner, what also it does is it keeps multiple copies of your data. So in case there is an issue with a node, there is a Paxos algorithm which keeps an eye, and as soon as a master is down, automatically says that, okay, this is a set of data for which was being owned by this particular node. Now this set of data is in another replica. Let's promote it. Okay. So all that, everything is completely without any manual intervention, and it's automatically taken care. Okay.
I think on the administrative part, would love to hear from our audience if anyone has any points of view on, what are their current challenges on the administration side. It could be around cost tracking, cost management, which you face with your current setup. And what are the questions or solutions that you have been seeking? And we can probably check with Saurabh on what his best practice recommendation is, and if specifically on any Google product, if there's a better way to do it. But would love to hear from the audience if anyone has anything to share.
Sure. Thanks, Anuraag. Okay, continuing. So see, now that Spanner is distributed, it gives you 5 nines of availability. The RPO and the RTO is absolutely zero, and some of the nuances of this I already spoke about. But if you want to get more details as to how a Paxos in Spanner works, or how is the data being distributed, I can definitely share some offline links with you. Or if you want me to cover it now, let me know. I can definitely give you some more details. In comparison to any other native database offerings in different CSPs, okay, there is something called as a maintenance window. Even in Google Cloud, we have different products like Cloud SQL, which supports MySQL and Postgres versions for the backward compatibility, and if you just want to lift and shift, right? But all these different different flavors of MySQL or Postgres in across all the CSPs that have something called as a maintenance window. At least once in a quarter, or once or multiple times in a quarter, your database goes down, right? For 15 minutes or 30 minutes. There are certain applications, although you have a lot of control as to when you want to do or when you want to apply that maintenance window, but there are certain use cases where you cannot afford this, right? So Spanner also gives you a lot of advantage from a maintenance window perspective, because there is no maintenance at all. So even that 15 minutes of downtime, you don't have to incur. Okay. If I also try to compare with the traditional system, there is one very important nuance towards, if I go back with MySQL or Oracle or Postgres. See, suppose there is a table, and there is a table with assume it's 1 TB table. Okay, and now because of the business requirements, you want to add a column or remove a column or change a data type of a column. Right? How do you do that? How much time does it take? So usually, whenever I execute a DDL on a table, it acquires an exclusive lock on it. And an exclusive lock means I'll not be able to perform any activity on that, correct? Until and unless that exclusive lock has been taken off. Okay. And the time of that exclusive lock directly depends upon what is the size of the table. Right. So if I have a table of multi-terabytes, it becomes very, very difficult for me to actually, add a column or change a schema of that particular table. So Spanner also solves this problem by allowing you to actually make any change in your schema, that is adding a column, removing a column, or changing of a data type at runtime. It doesn't acquire that lock. Internally, there is very complex thing or complex implementation of how it works. But for an end user, even if you have executed an alter table add column, even after that, you can do any writes, updates, deletes, reads, whatever you want to do. Okay. So even if you want to change your schema, there is absolutely no downtime that you'll have to use. Okay. Okay. Quickly touching upon some of the security and compliances. So Spanner as a database has most of the is adhering to most of the security and compliance like HIPAA, PCI, SOC. So most of those compliance certifications are there. From a data protection perspective, we give you all that option of encrypting the data using Google Managed Key or CMEC, that is Customer Managed Encryption Key. If you want to encrypt your data using your own keys, you have that option available. And as I told you earlier, it's completely ANSI SQL compliant, which means if you want to access a data, change a schema, or read, delete, update, whatever you want to do, like in terms of DDL, DML, it's exactly same as to how you used to do in MySQL or in Postgres. Like just select all, delete, update. So it's completely ANSI SQL compliant, so you don't have to go through a lot of changes. Okay. Another thing which I briefly touched about was okay. So when you spawn a Spanner cluster, you have two modes of deployment. One is a single instance where you want to have all the Spanner nodes just in a single region but distributed in multiple zones. So you have a single region implementation, and another is a multi-region implementation where you say that I want to actually distribute my Spanner nodes across multiple regions, one in India, one in Europe, and one in US. You can definitely do that. Okay. There are multiple other features with respect to the programmability or security or other features. I'm not going to get into all those features, but just giving you a glimpse of that, Spanner gives you all those features, whatever you expect out of a production grade traditional RDBMS database. Okay. I see there was a question.
Yeah, it's me. I'm just posing a question for the next section on Postgres, in case anyone has been part of a team that has recently migrated, but we can cover it when we move to the next section. Sorry.
Sure. So I think a good point. I can definitely also cover one more piece about it, Anurag, and which is just to make sure that, so when we were building this entire thing, right, we got a lot of interest from Postgres customers. And this has been a recent trend in the industry. People are moving towards Postgres, right? So, and the existing Postgres customers wanted to leverage Spanner. So what we eventually did is we created a Postgres interface for Spanner. What does that mean is, see, any Postgres client that works on a wire protocol. So what we eventually did is we created an interface which is compatible with that wired protocol. What it now means is, suppose you are using a Postgres database. So all your applications would be using all the Postgres compatible drivers. So now what you can do is you can have your applications intact. I wouldn't say it's a drop-in replacement. You will still have to do certain changes, but very minimal. Okay. So now you have your applications. You can use this Postgres interface for Spanner. So which means your applications will now connect to this Postgres interface, and this interface will internally connect to Spanner, which means your Postgres applications can now take the benefit of whatever Spanner offers. Okay, so like you, again, giving you another example. So say, for example, you were using pSQL as a client. Okay, we all use pSQL, right? So, and in case you're using Postgres. So if you're using Postgres and you're using a pSQL client, now the pSQL client can connect to a Spanner database using the Spanner Postgres interface. Okay, you were using /d, /x, /l, all the typical pSQL client, pSQL commands. Everything can now be executed on top of Spanner. So, which means that if you want to continue using your Postgres application, but you also want to get the benefit out of Spanner, you can use that using this interface what I just spoke about. Okay, cool. Moving along. See, so if I go back to the problems, the 5 problems what I mentioned about, we spoke about scale, we spoke about sharding, we spoke about replications, we talked about consistency, we talked about the operational hazards. But there is one thing which we did not talk about, and that was the HTAP use case. Okay, what is that HTAP use case? So typically it's the real-time reporting that you want to do, and you cannot afford to have even few seconds of lag. So you cannot actually run it on top of replicas. We get into all those staleness of data issues, right? So how does Spanner solves that? See, what happens if I tell you that you can run all that real-time reports on top of Spanner? You can definitely do that. But the challenge what we eventually would get into, that all those real-time reports would also use the compute what your OLTP use case is using, which means your report will consume more resources and your OLTP will starve for resources. And eventually your OLTP resources can get impacted with. Okay. And in fact, from a disk perspective, from a storage perspective, if you look at, if I've been traditionally using any MySQL or Postgres, if I try to execute all my real-time reports, it's going to use the same IOPS what your disk can offer. Whether it's in Google, we offers 30 IOPS per GB. So there is a limit to it, right? And in case your real-time reports are being using all that, then your OLTP use case might get a performance hit. Correct? So even in Spanner, that is the same case, right? So how does Spanner solves this? First of all, as I told you earlier, Spanner uses a Colossus storage. The storage is itself infinitely scalable. Okay, so you don't get into that IOPS problem per se. But how does the other problem Spanner solves, which is typically your starvation of your resources on your OLTP compute? So what we have actually done is we have created altogether an alternate path for your read queries, which now means if your application want to run any sort of reports, you can actually tell Spanner that I am going to run a report. I don't want to use my actual OLTP path. I want to use an alternate path. And Spanner being an intelligent database, what it says is, okay, if you want to use a read query, if you want to execute a read query, I'm not going to use the compute which is allocated to your OLTP. I'm going to spin off our new resources. Okay. Or in case you have already spun it off, then I'm going to just use that, and I'm going to use that compute to actually take the data or get the data from the infinitely scalable Colossus storage, so that even your IOPS doesn't get impacted. And I'm going to read the data from Colossus through an alternate read path and give it to you. Now, which means is, even if you want to execute all your HTAP sort of use cases, you can still execute on top of Spanner, because I'm not going to use the same resources which is allocated for your OLTP systems. Okay, so what we did is we were working with a customer where we benchmarked this. So what we did was we requested them to execute a real-time analytical query on top of their OLTP spanner compute. And this is, if you see the left side of the slide, you would see that their CPU utilization went up to almost 60 to 65% because of that analytical query. But eventually, once we gave them this alternate read path, you could see that there is absolutely no impact on their OLTP resources. So their OLTP resources just won under 0 to 5%. So the question from Jay Kumar is, when is the time to look for something like Spanner? This is the time. So see, Spanner is not something which is built for huge amount of IOPS or huge amount of data. As I told you earlier, it can even work with 1/10 of a node. Even if you have few hundreds or few thousands of operations a minute or an hour or a day, you can still come and feel free to use Spanner. You can just try it out. It gives you all these features
Sorry, Saurabh.
irrespective of your size or the load on the database.
So
Sorry.
what about the cost, Saurabh? We not typically use something like a pass, right? So when it comes to cloud SQL or something, so is it that we can just, even irrespective of the size of the database or the number of customers we currently have, are you saying we it is better for us to move to something like Spanner, so that as we scale we don't need to worry about it?
See, absolutely. I think as I said earlier, irrespective of your load size, you can start using Spanner. I'll tell you also a challenge. See, what I've seen based on my past experiences with customers is some customers really find it difficult to actually migrate to Spanner. See, because it's not magic, okay? And Spanner, because it gives you so much flexibility, so much benefits, it has its own set of rules that we might have to follow when we get into Spanner's journey, right? For example, any distributed database cannot work on sequences, right? So if you have your database and if you are using sequences, then we will have to modernize your applications. Okay, so we have to evaluate as to how the modernization journey to Spanner looks like. But to answer your question, definitely if you are on Spanner, you are future ready. Whether you are catering to 100 users or 100K users or 1 million users, Spanner doesn't restrict you. Spanner is infinitely scalable. We have multiple users who are using thousands of nodes to cater millions of operations a second. In fact, I can also show you one use case, Google Ads. Okay, so you could assume what would be the scale of Google Ads, right? In fact, they were earlier on MySQL. They had a sharded database and lot of similar problems which I just spoke about. And eventually we moved to Spanner. Okay, and in fact, that's what I was alluding to earlier, that it was our own problems that we eventually got to figure out a solution, and we invented all these different sort of native database that we offer as a part of our portfolio. So now Google Ads is running on Spanner.
So just to expand on Jaykumar's question, I think uh, so there are three products now, right? In the slide that you had around what was on offer. So you have Cloud SQL, which I think Jaykumar mentioned they're currently using probably. You have this new product Alloy, which I understand the difference, maybe not that clearly. So one difference is you call one as Postgres compatible, whereas other is more native. And now we're talking about Spanner, right? So uh, if you are in the RDBMS world and you've chosen at a particular scale to work only with Cloud SQL, I think the question probably is, what should you do? Should you move to Spanner now, even though your scale is not there to be scale ready in the future because the efficiencies from day zero to day? Or is it not a huge concern for you? You're already on GCP, just using Cloud SQL, and it's a thing that you can figure out down the road if you need horizontal scaling like NoSQL. I think that's what maybe what Jay Kumar was alluding to.
Okay, got it. See, if you're already on any database and you're not facing any problem, then of course over engineering is always bad, right? So you can continue be on Cloud SQL or whichever database you are. But yes, if you see a plan, if you see, or based on your projections, based on the traffic patterns, what you see in 1 year, 3 years, and you see that you're going to scale up and you need that agility, you need that scalability, then definitely, and from all the different parameters that I spoke about, scalability, agility, manageability, cost perspective, please keep a watch on all these different points. And if you think that Spanner ticks you, or Spanner gives you a solution of to for any of these problems that I just spoke about, then definitely Spanner is the right one. Okay. And if not, then of course these other traditional databases has been there for a very long time, serving some very complex use cases. And if you don't have any problem, you can continue to be there. So let me just read the first piece of the question, which is what to monitor continuously. Okay, got it. See, it actually, the answer actually is it depends. Okay, now no problem, Umang. That's totally okay. See, when I was working as a DBA, there were some very basic things that I always made sure that I kept an eye on. Started from CPU utilization, and the answer also differs from a database to database. Now let me just try to first answer it for a traditional RDBMS database. If you are on because you said you are on RDS in AWS. So see, starting from CPU, the deadlocks, the long running queries, and the memory utilization. That can be the P0s that you should always monitor. There could be other thing, but it depends upon your application. But primarily these, if there is an alert on any of these, what I spoke about, definitely it can eventually get into more wider problems. Okay. Similarly, if you are on a different database, like a NoSQL database, you can get into hotkeys. So the first thing what I would always keep an eye on is hotkeys. Okay. Let me just read your second question. Okay, so about the ORMs. See, my take on ORMs is it gives you a lot of agility. Okay, you should always build your applications using ORMs. I understand it is a very debatable topic. Some of you might not agree with me, but ORMs does give you that agility. Okay, the most prominent one has been Hibernate, right? At least for the Java folks, it gives you a lot of that agility. And see, being in an era where today you might be using one database, tomorrow you might be using any other database because of whatever reason it is, ORMs gives you that agility to hop. So always try to build your applications using one or the other one. And most of the databases, whether it's on any CSPs, gives you that support of at least most of the prominent ORMs. Okay, these days even GORM is a much widely used. So if you are using Hibernate, Django, GORM, you might get support for all of these. So it's always good to use ORMs. The third is currently wanted to know what is the best option I have in GCP ecosystem to save time series data, location data. Great. I think, see, when you talk about time series or a location data, it depends upon how you're trying to store it. If you really are trying to store it as coordinates, then you would need something like a PostGIS extension. Alloy is the right one for that. But if you just want to store it as an append-only lock and you're looking for huge amount of write operations coming in, huge amount of data coming in every second from millions of devices like an IoT use case, then typically big data is the right one, where you don't need a transactional compatibilities, but what you just need is an append-only lock sort of a thing. And these days, most of the track and trace applications are being built on top of Bigtable. Okay. So in fact, we have a referenceable customer, Aether, who has built in a very similar use case on top of big data. Okay, I think
Okay.
Jay's question, probably you can take
Yeah.
that.
That'll be for us. But yeah, I'll get to your question as well, Jaykumar. But thanks so much. We're 5 minutes over time, so I'll take a hard stop now. But Saurabh, Rahul, Anurag, thank you so much, as well as everyone in the audience, for your questions. To answer Jaykumar's question, you could follow our LinkedIn page. Jay, we'll be posting about tech sessions, insights from this session, as well as the upcoming sessions that we have curated as part of the series, as well as I'll be, because you've already registered, so you'll be getting more notifications about the upcoming sessions from us. But yeah, I really, really appreciate it. Appreciate the fact that all of you took out the time to do this. We hope that you found some useful insights, and yeah, thanks for joining in. Anurag, any last thoughts from you before we wrap things up?
I just want to thank you, thank the Google team, especially Saurav. Thank you so much for taking this session. Look forward to organizing more of these, and please keep, for the audience, please keep giving us feedback. We would love to tune these sessions to really cater to the problems you're trying to solve and make them even better. So thank you so much for your participation today.